Word problems like example 8 are extremely challenging because you have so much information and you have to work with a couple of different things going on in the problem. What I find to be the most helpful is to think about what the answer needs to be in. How many seconds? So we want seconds to be our final answer and to be the only unit left in the problem. The textbook goes about this a different way than I like to think about this, and they just start using some of the information, and at the end, notice that seconds is the last unit, and everything works out. I like to think of this in a backwards design, because if I know what my final units needs to be, then I can kind of work backwards from that in order to set up my problem. So what I mean by that is if I want seconds, then I look in the problem for another time where I'm given seconds. The speed of light is 300 million meters per second. Usually we would write the 300 million meters above the line and the per below the line. But it's okay to flip this with these fractions and to do it upside down. And the reason I want to do that is I want my final answer, I need to just be an S. I need my final answer to be in seconds. So I'm going to think of this as 1 second. Just doing my units all wrong today. Meters, there we go. 1 second over 300 million meters. It's the same rate, it's just now in the version that I need in order to get my answer in seconds. And now I know if I get everything else to cancel, then this will give me the right unit for my answer. So what am I working with? Well, I have meters, and I know something about the miles. Well, I don't have a conversion from meters to miles, but I do have a conversion from kilometers to miles. So if I can get my meters into kilometers, then I can use that conversion. So based on what we did in section 2.2, I know that there's 1,000 meters per 1 kilometer. And then I can use the fact that 1.609 kilometers equals 1 mile. And notice here that I now have seconds and miles, but I happen to know how many miles there are between the Earth and the Sun, or Earth and the Moon. I was trying to figure out how long it would take to get from the Earth to the Moon, and so now it's time for me to use the information about that distance. And so the units cancel, and that's just over 1. It's just a single quantity. And like I said, I know these problems are particularly challenging. You won't have to see a lot of them, and I will go through how the textbook does this to see if you like that better. I start with 1, and the first number in the problem in the top left, you always have to put into the calculator. So I have to put that first number, which is a 1 here. And then I see that there's 300 million below the line, so I'm going to divide by 300 million. It's a lot of zeros. Then multiply by 1,000, multiply by 1.609, and multiply by 238,857, and I get 1.28 seconds. Now what the textbook does is they start with the distance, because if you're trying to figure out time, then if you know the distance and you know the rate, you can divide that and you can get your time. So they start with the miles and then convert from miles to kilometers and then kilometers to meters, because we know that the speed of light is 300 meters per second. And it's the same conversions, and you'll see it's the exact same problem. It's just the way that you think about it and how you set this up. I'm using all of the same fractions. I'm just doing them in the backwards order because thinking of it this way might be easier for some of you. We have our 300 million meters per second. And even though typically we would have that flipped with the per, because of the way that we need the units to cancel. So word problems like this definitely are going to involve a little more work. You will not see very many of these problems.